All right, an equilateral triangle with sides of length 3 units has a circular arc centered at H. So this is our center of the circle. So imagine we have a circle going all the way around H. And it says the length of what is the length of a segment drawn parallel to GI with endpoints J and K. So they want this segment. That's what we're trying to find. So segment JK equals what? And it says express it in simplest radical form. That means using like a square root or a cubed root, that type of thing. All right. Wow, this has a lot going on, but some things that we need to know. This distance from here to here is our radius. So that represents our radius. Now if that represents my radius, anywhere from the center to the edge of the circle is also my radius. So this is also going to be my radius. So that side right there. So that's important to know. Those are equal to each other. All right, well that helps, or it will. And I know that the whole side length is 3, so it tells me that each side of my equilateral triangle is 3. That means all of these. This is 3 over here, this is 3 all the way from there to there. And what do I know about an equilateral triangle? They're all 60 degrees, and the way I got that, a triangle is 180 degrees, so if I just divide that by 3 sides, every side is going to be 60 degrees. So I know this is 60 degrees. And I know this is 60 degrees. And obviously this one's 60. But what I'm going to do is, since I already have this side right here, I'm going to break this into a smaller triangle. So I'm going to bisect this angle. That means draw a line right through it. And I've already done that, because that gives me this radius. So the reason I drew that line, that's the same as this side, which I know, or I will know. So there's my right angle symbol. And I'm going to use my special triangles. Now special triangles are like 30, 60, 90s for degrees, or 45, 45, 90s. And these are ones that you need to have memorized. So 30, 60, 90 would be like 1 square root of 3, 2. That's the ratio of the sides. And 45, 45, 90 is 1, 1 square root of 2. So this is one of those special triangles. We have a 60, that's a 90, so this has to be a 30. Remember, we cut that angle in half, so that's our 30. So what I'm going to do is use my ratios here to make a proportion. So I'm going to choose this one because I have a 30, 60, 90, and it would be 60 over 90. I like to write the angles first, so 60 degrees over 90 degrees. And what goes with 60 on my chart over here? 60 goes with square root of 3. So I'm going to write square root of 3 on top. What goes with 90? 90 gets a 2. And we're going to set that equal, we're making a proportion equal to the actual measurements from our diagram. So the only one I know here is this long side, which is opposite of the 90. So 3 is opposite of the 90, so next to 90 over here I'm going to put a 3. And then I don't know my 60, that's my unknown, that's my x. So I don't know this side, that's what I'm trying to find. So I'm going to cross multiply. I'm going to make this a little neater first off. So it's x over 3. And we're going to cross multiply here, so I have 3 root 3 equals 2x. I want to solve for x, so I divide by 2, divide by 2. And that's what x equals. 3 root 3 over 2. Now think with me for a second. If this is 3 root 3 over 2, then that's the same thing as this because they're both the radius of this circle. Then this also is another equilateral triangle. So here's what I just did. If you have a equilateral triangle and all you do is that, it's making another equilateral triangle. These are proportional to each other. So all you need to know is if you draw a triangle inside of another triangle like that, it's going to be the same angles and it's proportional on the sides. So this is still an equilateral, which means if this is 2, this is going to be 2. Or in this case, this was 3 root 3 over 2, then that means this is going to be 3 root 3 over 2. And that's your final answer. It's 3 root 3 over 2. All right, try this question on your own. Go ahead and pause the video, and I'll be right back with the solution. All right, and now for the solution. Okay, the perimeter is 12, and we know it's equilateral, so if we just do 12 divided by 3, that means every side is going to be 4. So 4 is this side, and this side. And remember, we're trying to find DE, so that means we're trying to find that side length right there. And recall from the other demonstration that if we can find this radius, so from there to there, then we've also found this radius. So these are going to be the equal in length. So I'm going to try to find this missing side, and that'll give me my final answer, because that'll give me the length of BD. All right, so remember this is a 30, 60, 90. So that's my 60. I bisected that, that made that 30. That's a right angle. So I'm looking at this triangle right here, right now. And I'm trying to find the radius. All right, so I'm going to write 60 degrees over 90 degrees. And I'm going to remember my ratios. It's root 3 for 60, and it's 2 for 90. And what are the actual numbers on my picture? Opposite of 60, I don't know that. That's my radius. I can call that R if I want for my radius. And my opposite of my 90 is a 4. So I'm just going to plug in a 4 there. And now the shortcut here is pretty sweet. How do you get from 2 to 4? This is just equivalent fractions. You multiply by 2, so times 2. So R is just 2 root 3. Or my radius is just 2 root 3. So that's this part is 2 root 3 from dB. And then remember what we did earlier. If you take a equilateral triangle and then you just make a smaller equilateral triangle out of it, I mean it's still an equilateral is my point. So if that's 2 root 3, that means that DE is also going to be 2 root 3. And that's your answer.